Hello all, today in this video I am going to show and demo for face emotion recognition in Python. In this video we have worked with VGG16, that is an transfer learning model only. So in the next video we will be working with some other algorithms. The data set we downloaded from Kaggle. You can just give a spatial expression recognition data set in Kaggle, means you will just get that link. So initially the libraries which we are needed, we are just importing, and then we are loading our data set. We are having nearly two data, that is training and testing. Training will have nearly 80,000 data, that is while compared to training, testing data will be low only. Then we are making a definition called low data. Within the definition we are making some lines or scripts to load our data. For that we are loading our image by using the imread function, and then we are resizing an image. The image size we will be giving as 48 into 48. Here we have given 48 into 48, and then we are making the x variable and the y variable. For this we are using the train directory and also the testing directory. Then the x train and y train are determined by using the training directory and the image size. So you can notice the training directory is having nearly 28,273 images. The labels, that is we are having is nearly 6 classes, that is angry, fear, happy, neutral, sad, and surprise. Likewise, then we are getting the test variables. For that we are getting the testing directory. Here we are having nearly 7,067 images, and then we are making a definition to plot the samples. Within this definition we are making the script to subplot and all. So then we are using this definition to subplot or x train and y train variables. That is what is nearly we are having 6 classes. The class 6 images in the 6 classes are displayed, nearly 10 images displayed. Why? Because here we have given 10. So first come the angry, next is the fear, next happy, next neutral, next sad, next surprise. Then we are getting that is we are converting this y train value to categorical and also y test value to categorical, and then we are importing our VGG19 model. Sorry, I said VGG16, it is VGG19. This VGG19 we are importing within a model called base model. Then we are getting its summary. So these are the layers which is having in this VGG19. Next you can see that base model which we have defined there, we are using here by initially we are calling the sequential as 6. Here we have given number of classes as 6. If you are not interested give number of classes here as 6, means here directly itself you can give a 6 instead of calling number underscore classes. Activation function, here you are using softmax. Also we are using flattened layer, dense layer with the 1000 units, and the activation as a ReLU, and here activation as softmax. Then we are defining a deep model. Within the model we are describing the compile function with the binary cross entropy, and the optimizer used is RMS prop with the learning rate of 1 e power minus 4, and the metrics we are setting as accuracy. And then history, within the history we are calling the x train, y train, epochs, and batch size and verbose as 1. Epochs we have given as 10, batch size we are declaring as 128. This deep model definition here we are using it, and then this will just run our model and it will display the values like loss and accuracy. Here you can notice we get some little loss only, but as the epochs increases, it values will be increased. But here we have worked for only 10 approaches. Why? Because its time is very high. You may notice that previously we used nearly 20,000 images for training and testing 7,000 images. This will increase our time. So only we have made as 10. So if you want to work with some other approaches means you can work with, not an issue, but the time will be increased. Then we are making a definition to plot the confusion matrix with the x ticks to y ticks, then tight layout, then x label and y label. Then we have got, by using that definition for the confusion matrix, here we are using it, and then we have got the value for the confusion matrix plot. Before that we are testing our model by using the predict function and the testing variable. Here you can notice we have got an test accuracy of 0.25%. Then this is the confusion matrix for the model which we have got. Then we are declaring the testing prediction. For that we are making some where scripts, and then you can notice that we have given nearly 5 images, both every are angry images and the predictions, but we got as happy. Why? Because our accuracy is 0.26 only. In the next we demo we can work with some other algorithm and we can improve the accuracy. At that case we will get this predictions. Then we are also making to display this prediction variable. At that time initially we have given an angry class, but we have got happy only. Next we have given fear class. For that also we have got happy only. Here also the same thing, it is correctly predicted only. Here also incorrectly predicted only, but here happy, because whatever you gave we will be receiving happy only, because our accuracy is very less. We have to work with some other algorithms. In that case we may get some better prediction. So this is the code for facial expression recognition with Python with VGG19. In the next video we will be working with some other code. Thank you.